Alright, chemistry. This is the answers video to day 39. I'm just going to do this by hand rather than PowerPoint the way day 38 was done. Okay, so let's get started. These problems are a bit more sophisticated than the ones on day 38, so practice these and you will become good at them. So seawater has a density of 1.027 grams per milliliter and is comprised of sodium chloride and water. What is the molarity of a solution that is 3.5 mass percent sodium chloride? Okay, so there's a lot going on here. So first let's start with the density. Density is what relates the mass, or how much a substance weighs, to how much space it takes up. That's called density. And you can write that as an equivalency like this. Okay, so it's 1.027 grams, and we're dealing with the solution. The seawater is the solution. Okay, I'll just write that right here. Alright, so that's the mass to the volume of the solution. Alright, now it's comprised mainly of sodium chloride, that's NaCl, okay, and water. What is the molarity of a solution that is 3.5 mass percent sodium chloride? So we talked about what to do with a mass percent. You assume that you're going to use 100 grams of the solution, therefore you're going to have 3.5 grams of the solute, in this case sodium chloride. So we'll just write that here. Okay, just like that. Alright, the only other thing we need is molar mass for NaCl, so we'll write that. You can calculate that. I'll just go ahead and give that to you here. Okay, there we go. That's everything we need to get started. So now the question is asking for molarity, and except for one special case, we always write that as moles of solute, in this case NaCl, per liter of solution. Okay, and we're going to start with the mass percent that they gave us here. So start way over on the left on this. You're going to need every bit of space you can get. Okay, there we go. All right, so now we have a two-story problem. A top story, a numerator, and a bottom story, a denominator. All right, so what we need to, on the top story, we need to get from grams of NaCl to moles of NaCl. And that, of course, is going to be a molar mass conversion. Okay, so we'll go ahead and write that. And which one goes on top and bottom? We need grams to cancel out and moles to appear on the top. Okay, grams cancels with grams, and the only thing you have left on top now is moles of NaCl, which is what you want on your final answer. So we're done dealing with the top. Now we just need to deal with the bottom, and liters of solution, and we need to get that, whoops, I made a mistake here. I hope you caught it. It should have been what I have here, 100 grams of solution. Okay, so make that correction. Okay, so now we got it right. 100 grams of solution to liters of solution. So we got to convert from grams to liters, and so let's go ahead and do that. So we have a conversion for that, and that's called the density. That's what the density does. It gets us from mass to volume. So let's go ahead and do that. So we need grams to cancel out, and we're going to have, in this case, milliliters up here on the bottom, which is a derivative of liters. So let's go ahead and do that. Grams cancels with grams. Now we have milliliters on the bottom. We need to get to liters, and so we can use one of our three standard conversions. And of course, this is true for anything, but we're interested in solutions, so you always want to state what the substance is so you don't get it confused with something else that you might cancel with. Okay, so it's this, and now we have liters of solution on the bottom, which is what we want. So everything is set up properly. Multiply 3.5 times 1.027 times 1,000 divided by 100 divided by 58.44, and I didn't leave myself a lot of space, so I'm going to write the answer up here, 0.615. Okay, and that's your answer. That's molarity, or molar. Okay, all right, let's move on down, and we're going to go to 2A. All right, so this is if 1.5 liters of 5 molar solution of sodium chloride is diluted. That's the key word. It's a dilution problem. To 6 liters, what is the molarity of the new solution? So very simple formula. M1, it's the molarity before, V1, the volume before, equals M2, the molarity after the dilution, V2, the volume after the dilution. Okay? Okay, so we have 5 molar for the molarity and 1.5 liters for the volume. We want to know the molarity after, that's M2, and the volume, be careful here. It says it's diluted to 6 liters, okay? You got to be careful. Is that what the final volume is, or is that how much is added? In this case, that's what the final volume is. So we're going to put that down here and do algebra. And we solve for M2. And that's going to equal 1.25 molar. So our lemonade was way too strong. It was 5 molar. We put a bunch of water in to make it 1.2 molar, reduce the concentration. Okay, we'll move on to 3. Now in class I did 3b instead of 3a, so I'll go ahead and do that one here. So a solution is made by dissolving 29.5 grams of glucose, and there's a formula for glucose, in 0.2 kilograms of water. What is the mass percent of the solute in the solution? Okay, so let's go ahead and write the formula for mass percent. Alright, so there it is. So now we need to know the grams of solute. Well, that's given to you right here. It's the glucose, okay? So it's going to be grams of glucose, and then over the grams of the solution. So you have 2.2 kilograms of water. And the solution is the water plus the glucose, okay? So first we need to make a couple of conversions. You got a lot of space down here. So let's convert kilograms to grams of water. And one of the standard conversions is 1 kilogram equals 1,000 grams of anything. Going to equal 200 grams of water, okay? So the solution equals the water and the glucose together. And I'm just going to abbreviate, rather than write this formula, it's GLU. I just call it GLU, okay? It makes it a little shorter and simpler, and that's going to equal 229.5. Okay, good. So now you can come up and finish the problem here. Okay, get that times 100%. Okay, and that's going to give us 12.9% glucose by mass. That's the way you would say that. Okay, right there, right there. Okay, keep going. 4a. So an aqueous solution of hydrochloric acid, HCl, contains 36% HCl by mass. Calculate the mole fraction of HCl in the solution. Okay, so we're going to do what we said we always do. We're going to turn the percent into grams by choosing a 100 gram sample of the solution. Okay, and there we go. Now to get a mole fraction, we need the grams not only of the solute but of the solvent, of the water itself. So how do we get the number of grams of water? Well, remember that the solution is the solute plus the solvent. It's the HCl plus the water. So we're just going to do a subtraction problem. Okay, so that's 64 grams of water is what we have. So now we're looking for a mole fraction. So we're going to have to convert grams of water into moles of water. So we'll go ahead and do that. And we're going to use 18.02 grams per mole for water. Okay, and that equals 3.55 moles of water. Okay, so now we have to do the same thing for HCl. So I'm going to come up here and calculate the molar mass of HCl. You have 1 hydrogen, 1 chlorine, both of these off the periodic table, and that's going to give us 36.46 grams per mole of HCl. So we'll do the calculation using 36 grams of HCl. Okay, and do the math on that, you get 0.99 as a moles of that. Okay, so now you're ready to put the two together, and its mole fraction is this, the Greek letter chi. Okay, there it is. You don't multiply by 100% with mole fraction. Okay, so now we can plug in the numbers that we have. 3.55 for water, 0.99 for the HCl. And we'll do the math on that. Okay, and rounded we get 0.22. It's not a percent, there's no unit of measure, it's just 0.22. They call it a mole fraction even though it's a decimal. Okay, we're on to problem 5a. How many grams of NaOH are required to produce 0.65 liters of 1.4 molar aqueous solution? Okay, so one thing we're going to need in this problem, well, let's set it up first and then we'll see what we need. Sometimes you have to do that first. So you're looking for grams of NaOH. Okay, and now we're going to start with, again, we said that molarity is the primary number in this problem. Liters will come in later on. So we're going to come over here and write 1.4 molar, way over on the left. There we go, liters of solution. Okay, now we have to look at where we have to go. We have to go from moles of NaOH to grams of NaOH. So that tells us we're going to need a molar mass. And so I'm going to go ahead and write that out. I'll give that one to you. You can calculate that. It's 1 sodium, 1 oxygen, 1 hydrogen. And that nicely comes out to be exactly 40. Okay, so there's the equivalency. We need to plug it in here. We need moles to cancel out, grams to appear on the top. Moles cancels. And the last man standing is grams of NaOH. That's what we want on the top. Okay? So now we got to go down to the denominator. We need to get from liters of solution to nothing. And we've done this one before. And we're given a number in the problem. It's 0.65 liters. So it's in liters, not milliliters. So we don't have to make that second conversion. We made it in an earlier problem. So you're simply going to put that up here. Liters of solution cancels and cancels. And we have no units left on the bottom. So everything's good there. So now you go ahead and multiply everything that you have here. Okay, and we come up with 36.4 grams of NaOH is what we need to go and get out of the store cabinet to go ahead and make this solution. All right, last problem, we go down to 6a, and it is you have 750 milliliters of 1 molar HCl solution. You would like to dilute, there's that word right there, you would like to dilute this to 0.6 molar. How much water should be added to the solution? So a couple of things I want to note here that are different from the earlier problem. First of all, we do start with the same formula. All right, and we'll go ahead and plug in. So we have 1 molar. And now we have our volume expressed in milliliters. And that's fine. It's okay. That means you get your answer in milliliters when it's asking for volume. If they started you with milliliters, they probably want you to finish with milliliters, okay? So we're going to leave it. You don't have to convert to liter. Okay, and we're trying to find, okay, and we're trying to find a volume. So they're giving us the molarity that we're going to end at, V2. All right, so we just do our math, cancel there, and when you do the math, you get V2 equals 1,250 milliliters. Okay. All right, so is that your final answer? No, got to be careful. That's the final volume. They're asking how much water should be added. So you started with 750 and you ended with 1250, so you have to do a subtraction. Okay, so you added 500 milliliters to go from 750 to 1250, and that's your final answer.